Good afternoon. Hey, there. All right, I like a lively crowd. Perfect. So I'm Matt.
I'm Mark.
Hey, we're going to talk about some data in the Azure cloud. Before I get started, first, congratulations. You found the ballroom in the other building. Good job. I was a little late. I was running between the buildings, not sure exactly where I was going, so good job to you. Second, it's the afternoon. Most of you just eat lunch? Okay. I'm a high energy guy. I will try to keep you awake. Everybody's going to get the afternoon lull. I know it's the second day of a conference. We'll do everything we can to keep you awake. A couple of questions to get started, just a little bit, so it helps us a little bit know who you are. How many of you have stuff running in Azure? Okay, I'll ask the opposite question. Who doesn't have something running in Azure? It's perfectly acceptable. Who is running Azure Data Factory? Oh, good mix. How about Azure SQL Data Warehouse? Okay. Azure SQL DB. My favorite one. Ooh, a lot. How about HD Insight? Okay, so we got a good mixed crowd. That's perfect.
We're Excel users.
Yeah, of course. Yeah.
Awesome.
So you've come to the right session. So we're going to talk about building kind of analytic solutions. We got to be on 5 here. We're going to talk about building kind of analytic solutions in the Azure cloud. We will mix a little bit of kind of high-level scenarios. We're going to walk kind of a demo scenario. And then we'll talk specifically about some of the products and the capabilities that are either announced or have recently been announced or that are available in the products. This is intended to be interactive. If Mark and I stand up here for an hour and 15 minutes and just talk and nobody asks questions or things like that, it's not usually the best use of time. So if you have questions, if we say something you're not sure about or want some clarification, please raise your hand. Either step to the mic or repeat the question so that it can be on the recording, okay? But this is truly intended to be interactive. So we're going to walk through a hypothetical scenario, water consumption. So really what we're going to do is we're going to kind of go through the process of how do we grab the data, how do we process the data into Azure, how do we land the data, and then how do we ultimately report on it. So we're going to kind of build that whole pipeline here and talk about some of the best practices of the products, some of the integration points, some of the new features as we go. So that's kind of the basic kind of summary of what we're going to do for the next 60 minutes or so. As you can see, we're going to collect a bunch of data sets. So we're going to pull from a bunch of different places, NOAA, drought.gov, places like that. We're going to take all that data. We're going to land it. We're going to process it in a couple of different ways, not only with SQL Data Warehouse and ADF. Mark's got some interesting things to show you in the way that we can process it with some of the other products. So we're going to give you kind of an overview of how all these things work and how they fit. We'll ultimately land it in a SQL Data Warehouse, and then we'll build a report off the top of that. So we'll kind of walk you through the flow. Really, it's that whole flow from beginning to end that we're kind of trying to show you some of the best practices and integration points, as well as then diving deep on, hey, here's a specific thing about a product or a feature that we've just released that we can talk about and give you some insight on how that works. We'll be playing kind of a couple of different scenarios or personas here. Mark's going to play kind of the ETL developer, data developer, moving the data from one location into the cloud, for example. And I'm ultimately going to play like the analyst role. So now that I've got that data in a SQL Data Warehouse, how do I go build some basic queries, and how do I report on it? The key distinction there will be I'll show some of our new stuff with our new Gen 2 offer that came out just in the last week or so. So ultimately, the outcome of this, it's like a magic trick. I'm a big fan of, there's a show called Penn and Teller, Fool Me. And really the idea is that you go in and you try to do a magic trick. And there was a great magician. He went in and said, here's the trick. And he actually explained the trick. And then he tried to show you how he did it. And you knew what the outcome was, and you knew where he was starting, but you could not figure out how he did it in the middle. Fortunately for you today, we're not going to be sleight-of-handing anything. This is ultimately our output. We're going to build a simple chart that shows population growth, which is kind of the light blue line there, with drought conditions. And the color indicates a deeper drought. So as you can see, we're just looking for a simple correlation. If population grows, do we see more drought conditions? We're going to show you how we took all these disparate sources and got here. So this is ultimately the outcome of where we're going. So from here, I'm going to drop over to Mark, and he's going to start with how do we go from just an idea to start to building and aggregating that data.
Awesome. OK, so thanks, Matt. One or two quick further dives into data integration before I go into Data Factory a little bit more. I know that several of you raised your hands around being Data Factory users, which is awesome. Thank you so much. And let me ask a question. Who's using the older sort of V1 original version of Data Factory? Just a few. And how about the newer, the V2 updated version? Excellent. Are you typically, you can just shout this out, but I'm curious, are you typically building your pipelines through code and through PowerShell scripts, or using the UI to build pipelines? C#, UI, C#. Okay. So what I'm going to actually demonstrate today, when we jump to the demo because of time, is more of a sort of visual data engineer building a pipeline that is meant to take all these different sources of water and population and drought conditions and weather, and we're going to munge that together to create an analytical solution in Data Warehouse. So we're going to land the data in Data Warehouse, and then Matt is going to jump back up here, and he's going to show you how to use Data Warehouse and how to use Power BI to report on that data. Okay, so one other thing. Anybody use other tools for data integration, like maybe SSIS here in the room? Excellent. Okay, so what I'm going to do is I'm going to show you the UI for Data Factory to do this job, to do this task. And you're going to see there's a lot of similarities around what we're doing with a graphical experience for Data Factory with SSIS. But of course, Data Factory is all in the cloud. All right, so let's jump into how we're going to build this solution. So what we're going to do is Data Factory is going to be grabbing these files from different sources. We're going to grab files from S3 from Amazon. We're going to grab some NOAA data, so some oceanic administration, blah, blah, data. We're going to also grab some data from blob storage, which is going to be some county information. So we're going to have information about location, lats, longs, FIPS codes, those sorts of things. We're also going to use a REST API so we can get weather data, the most recent weather data from a REST API. These are obviously not the only ways you can acquire data into Data Factory or through Data Factory into Data Warehouse, but these are just kind of the things that we're going to demonstrate today. Then we're going to transform, clean, normalize that data, essentially data transformation with Data Factory. And the way that Data Factory works today for this task is that you dispatch that task to execution engines such as Data Warehouse or Azure Databricks, HD Insight. Okay, this is another question I meant to ask. I'd love to see sort of, again, please just shout out, make it interactive. What are some of the transformation engines that y'all are using with Data Factory? Is it HD Insight, SQL DB, none of the above? HD Insight. Anybody using Azure Databricks yet with ADF? Try a little bit, okay. If you didn't succeed, please see me afterwards. So the reason why I ask is because we have a lot of different ways that you can transform the data, and we're trying to kind of optimize that path to get from disparate data into a solution architecture, into normalized data that is consumable, in this case by data analysts. And depending on what your sort of favorite languages or platform to use, we support those within Data Factory. And I'm always curious, so maybe afterwards, if you'd like to kind of, I'll be here for a little bit after the session, we can talk a little bit about which engines you're using there. Okay, so then after we build it, we schedule this. This is where you operationalize and productize your data pipelines. So with the latest version of Data Factory, we have a scheduling capability where you build a wall clock scheduler, or you can use event-based scheduling. You can still do time windows as well. But that ETL pattern is a very classic. This is one of the reasons why I brought up SSIS, because a lot of folks who've done ETL and data integration in the past have used tools like SSIS and scheduled those jobs through SQL Agent Job to run on some kind of a nightly schedule. So that's supported in Data Factory. And then, of course, you need to monitor those pipelines, and then you need to store all that normalized transform data into Azure Data Warehouse for your analytics. Does that pattern kind of make sense? Is this kind of similar to what you're all sort of doing with Data Factory today in your jobs? Or see if you had nods. That's good. Go ahead. Shoot. Oh, the cost. Yeah, absolutely. We can talk about that. We can talk about that at the end. We're going to save some time at the end. Why don't we dive into that then? Because the costs, of course, are going to be, just real quick, just so you understand how the cost structure works. Data Factory is based upon, the V2 version is based upon the number of activities that you run. And then there will be costs associated with your storage of that data, of course, at the outset, at the end of the pipeline. as well as the execution engine, the time spent doing the transformations. So that's how it all works. Then we can talk about how that's affected by how you decide to use the different engines. So if you haven't been using Data Factory in the past, just so you know, hopefully this has come across already. These are the sort of 4 tenets for the product group that we keep in mind as we build new features for Data Factory going forward for the roadmap. We want you all, as data engineers and data developers, to be as productive as possible. We're trying to incorporate as much codeless capability as possible to be able to accelerate your time to production. It's hybrid, so we're focused here, of course, in Azure, but at the end of the day, we have gateways or self-hosted integration runtime, it's called, that can communicate back and forth with your on-prem data as well. A very popular feature in Data Factory. Serverless in the sense that Data Factory does not require you to do with like SSIS. You don't have to install software. You don't stand up a client-server sort of architecture. It is all in the cloud, and it's scalable. One of the big real value adds to using Data Factory for your integration in Azure is that it leverages our own data movement as a service in the back end, right? So auto scales, auto detects the regions, the most appropriate region to move your data through the fabric of Azure as you're moving from one source to another. So it's very optimized in that sense. You don't have to worry about those sorts of things. All right, so this slide that I have up here is if you've stopped by our booth, we have a booth that's dedicated to this whole architecture solution, analytical solution space called Modern Data Warehouse over in the Expo Center. And this is very similar to what we show up on the screen. And this is kind of there's like 20,000 different ways to express the same idea. But the primary thing to get out of this is that we want to be able to acquire data from any source at any speed, any velocity. It doesn't have to be, normalized. It doesn't have to be relational data. It can be non-relational data. It can be from a database or files. So we kind of expand upon what SSIS has done over the years with very, very, well-defined sort of schema-based data integration, and we enable really any kind of data sources, and then you ingest those through that data movement as a service, store it into whatever stores that you need to. A really common, I don't think this slide doesn't get this across very well, but a really common pattern is that store section, I guess it does kind of say it there, is that we land the data into sort of a staging area like a data lake store or Azure Storage, and that becomes a place where you can then divide that data out to the most appropriate sort of, think of kind of like the polyglot persistence kind of pattern, where you put data, maybe that's faster moving data goes into Cosmos DB. The analytical data could go into Azure Data Warehouse, and so on and so forth. At the end of the day, you end up on the right-hand side, which is all of the business value that you're getting out of doing all this hard work. And that's what Data Factory enables. So 1 or 2 more slides. Yeah. So just kind of refine that into what we're going to show today. I talked about the sources, the weather, REST APIs, the drought data, the counties, the NOAA data, all in different sources. We can connect to any cloud. We can connect to on-prem. Data Factory is going to orchestrate all of this and is going to operationalize it. Now, when we get into the transformation piece, we're going to use a Databricks to transform the data. We're also going to use SQL Data Warehouse. So it's not a one or the other. You can leverage multiple engines to transform data within a single pipeline. They're all transformed through what are called activities within a pipeline in Data Factory. And we're going to land the data in Data Lake Store. And then we're going to use Polybase to load Data Warehouse. Polybase being the most optimal way to load data in parallel into SQL Data Warehouse. In our demo, we're not going to show analysis services, but it's a very common way to build those sort of data marts, those cubes around all the data that you're storing in Data Warehouse. There's obviously many other patterns that you can leverage. I'm sure Matt will touch on some of those. But a common pattern that we see is analysis services being used in there. And then we'll show at the end, if we do it right, we will end up with the report in Power BI similar to what Matt showed the picture of earlier. Last thing I want to make sure you understand from Data Factory is that these are all the different components that you work with. So when I bring up the UI, you'll see that I'll be in the pipeline builder in the UI. And the pipeline is made up of several activities that are sequenced together. You can sequence them or you can have them run in parallel. We have a link service that has the connection and credential information about your data sources and your execution engines and your data targets, your sinks. Data sets describe the data that you're working with. And then integration runtime is what moves the data around throughout all of the fabric and on-prem. So So you see at the end, what happens on the right-hand side is Data Factory moves data and it dispatches transformations. That's really the crux of what Data Factory is doing. And let me move over to my laptop and see if this works okay. Beautiful. That is not Data Factory. That is SSMS. There we go. So here is a Data Factory that I built for this demo. Now, by the way, what I did was, since we don't really have, it would be nice to have done maybe some sort of a hands-on lab or an instructor-led lab or whatnot for this kind of building this end-to-end. I'll show you how I built it and all the components, but I did take this entire set of pipelines. So you see on my screen on the left-hand side, the Canvas for Data Factory UI. All the way at the far left is a list of pipelines that you've created within this factory. So top level is a factory. That's essentially your account where all of your entities live. I have pipelines, data sets, and I have integration runtimes and link services. And within those pipelines, they're all listed on the left. I'll go through those in a minute. Data sets, again, like I said, they describe the data that I'm working with. These can all be exported as an ARM template. So there's an ARM template export right up here. And I exported all this already and put it on my GitHub. We have links to the full demo at the end of the slides. So you'll be able to capture those, or I'm sure you'll all get copies of the slides as well. If not, I'm going to make sure that that I post these on SlideShare or wherever as well. But all the information will be at the end. So the full demo is available to you there. I also have the database schema. So just to reiterate, this demo is for, that is not good at all. There we go. This demo is essentially showing you how to build a solution architecture for water consumption in drought conditions. So you see the tables are going to have that sort of information about counties, locations, time, weather, and drought conditions. So we have to load all of those up, and this whole database schema is also exported on the GitHub for you to play with as well. One last sort of thing about the GitHub, when you see it at the end, I also have a full lab out there with about 12 different segments in it that you can walk through to build a different demo with different data from start to finish. So go ahead and check those out, and I have my Twitter at the end, so feel free to hit me on Twitter in terms of if you get stuck on any of this stuff, okay? Before I jump into the demo, any questions so far? Is it pretty clear what we're trying to accomplish? Yeah, go ahead. Yeah. Yeah, good question. So the GUI interface, the question was, is the UI the only way to build these pipelines? And no, it's not. We have a full SDK and REST API. Another really common way to build these is through PowerShell. Those sort of mechanisms of using those tools are typically used for folks who have many, many pipelines and entities to build. If you had to build 1,000 pipelines, doing it for the UI is going to take you a long time, right? But if you stamp one out, export the ARM template, use some PowerShell to make the small changes in each one that you need to make. A really common scenario is customers of ours that use Data Factory that are SaaS providers that have their own solution and running in Azure that have multiple customers. They'll have a copy of a pipeline for every customer. So make small changes to it for each one of those customers based on a main template. Build a template in the UI and then stamp that out and then use those. Yeah, it's a really common thing. Yep. All right, anything else? Sweet. Okay, so what you do is essentially, let me actually start from a new one just to show you what a fresh new one looks like. So you just have a new pipeline, which is going to be a blank canvas. And if you're familiar with SSIS or sort of other data integration ETL tools, how am I doing on time, by the way?
It's down in front of you.
Yeah. I don't want to step on Matt's time. Is you have these categories of essentially what we call control flow objects that you can use. And ADF terminology, we call these activities. A little bit slightly different name in SSIS, but same kind of concept. That's not pretty clear on the screen. Let me expand this out a little bit. So what happens when you work with these is you just start with whatever sort of beginning stages you want to work with. So what I did for mine for this demo is because I need to move data from many different sources into Data Warehouse, I used what are called copy activities. So you'll see the name of the activity across the top of each one, which is copy, and then a specific name of that object. So the instantiation of each has its own name. So you say I'm loading weather, I'm loading all the different sort of data. So the copy activities here, you drag that on, and then you go into the bottom pane and you will configure that. When you configure your activities, what you're going to do is you're going to point to the data that you want to work with. So in this case, in my load weather, Let me bring this up a little bit bigger for you. In my load weather, oh, it's right here. I'm picking the data set that I want to work with, which is, the first one I'm doing is the REST API. So I'm using the HTTP source. You'll see a whole bunch of different sources you can work with. Let me show you that. So we have 74, 75, I think it is, different connectors out of the box. So when you make a new copy activity, you can make a new data set, and you'll see all the different sources that are available to you, essentially connectors that are available to you here. We also have some generic ODBC or sort of ways to connect to non-sources that aren't listed on here. But we support all of these, and we continue to come out with new and generate new connectors as the markets and customers like yourselves demand new connectors. So when you connect into that data, you need to put your credentials in there. So we have a credential manager capability that is all here in your connections. So these are my actual connections to those data sources. And I messed up my screen. There we go. So you see at the top, I connected to Key Vault. Very important to know that within Data Factory now, the way that you might want to think about storing your credentials for your different sources and destinations is to use Key Vault for that. So just use secrets, and you can access those throughout. But you'll see my connections into Databricks, into Data Warehouse, into S3, and all those sorts of things. Those are linked services. Now back into the actual pipeline itself. When you define the copy activities, in this case I'm acquiring data, you have to sync it somewhere. So I am syncing directly into Azure Data Warehouse for mine. That's not a way that you have to work, so it'll have my connection information stored in my link service. It'll be able to interrogate my data warehouse and find all the tables that I have available to me to load in there in real time. Now, a more common pattern would probably be land that into blob storage or data lake store so that your data scientists and other folks can access that data instead of using data warehouse. Because you'll want to then maybe use that as a working area and then polybase what you want to use into data warehouse. So I think I have show you how that is working here. So in your settings for your copy activity, when you connect into data warehouse, you'll have the option of what we call enable staging. Enable staging will use blob storage to take the data out of your source, put it into a staging area, and use polybase to load that into data warehouse. So I'll let Matt tell you a little bit more about, I'm not sure if he touches on it, but you can always ask afterwards to learn more about polybase, essentially parallel loading and loading at scale into a data warehouse. So last thing I'm going to show before I kick one of these off is that I'm going to cook the data in Databricks. So I'm using the Databricks activity. And our activity right now is limited just to notebooks within Azure Databricks. We're expanding upon this capability as we speak. So the way that I do this is I have the data coming in, I'm landing it into blob storage, and now I can use Databricks to work on that data. So I have a very, very simple, not being an expert Scala programmer, I actually cheated and went to Spark SQL because I'm a database guy. So at the top, all I'm doing is just mounting essentially my, maybe I'll move that off so you don't write down my key. I am mounting my blob store to a path on my Databricks cluster. Now the data is available to Databricks. And so at the bottom, all I'm doing is essentially bucketizing. I'm just taking FIPS codes and I'm putting those into groupings. I'm just grouping by FIPS code to make buckets of data that will get stored into Data Warehouse. So I'm writing back out to a CSV through Databricks. So that allows me to transform the data at scale, and then when that's done in my pipeline, what's going to happen is I have lost my screen. There we go. When that's done, I will then load those county buckets into Data Warehouse. Okay? So just to show that that's one path. The other path I do is I also aggregate. I'm also doing an aggregation right on SQL DW. So that's the ELT pattern. Extract, land in Data Warehouse, transform there. I'm using a stored procedure. So you'll see in my link service that the stored procedure name will not show up because it's a demo. But if you download this, you will see it. Essentially what it's going to do, it's going to run this stored proc right here, which is called bucket precipitation attribute. So I'm bucketizing other attributes, but I'm showing you how to do it in T-SQL. And this is just essentially looking for properties. I'm doing some coalescing around null values to NA, and I'm doing this for the NOAA data, so the same kind of thing. So the whole idea here is I've taken raw data, I have refined it with the factory, and I'm going to load it. Now what you do then in the UI to actually actually test this out is you can debug it in real time right here, or you can make a trigger on it. So you can trigger it right now, so it goes to the live service and runs it, or you can schedule this for another, for a regular daily run or whatever. I'm just going to hit debug on this and let this run. Now, what's going to happen when you debug is it's going to issue a run in real time, and you'll see the output right here as you are designing your pipeline. So you see that the first activity is going to be activity by activity. The first one is going to be acquiring the data from the REST API. It's going to be storing it into ADW via Polybase. While that is happening, let me ask if there are any questions. I'm just about down to 2 minutes left here on ADF. This is exciting, by the way, when you watch this screen just sit here like that. It is mesmerizing. Yeah, go ahead, yeah. Yes, yep, yes you can. The question was, can you connect to storage accounts to SAS keys? And yes, you can do that. So my first activity completed, now it's on to the next activity. By the way, this sequential way of doing things is not necessary. You can do this all in parallel. So if you download this, you will see that I also have examples of doing this in parallel somewhere. In the GitHub README, I explained it all. Yeah, so you can do these all in parallel. You don't have to have a sequential line connecting these. These can be all in parallel. You can write this in JSON yourself. You can write it in PowerShell. The exact same thing happens. Let me finish this up here. So this thing is running. So you see the indicator this is running. When you click into each of the activities, you will see details of what it actually did. So in this case, it brought data in from a REST API, put it into blob storage. Remember the staging area for Polybase? Loaded into ADW. I didn't have to write any code to do that. I didn't have to learn about ADW. I didn't have to learn about Polybase. I clicked the box that said use Polybase, and it did it. So I'll let that continue to cook, and maybe at the end, if we have time, I'll show you what happens. Because at the very end, I sent an email to myself saying that it succeeded. So the question was, do I pull data from Data Lake Store into Data Warehouse? Is that using stored procedures? Yeah, absolutely, you could do that. Yeah. Yeah, so I just happen to be using the copy activity just because it was the easiest way to kind of do it here. But yeah, you could do all of that through stored procs. Absolutely. So what, in that case, when you do that mechanism of what the question was just about running stored procs, ADF at that point becomes an orchestration engine and just orchestrating your stored procs. We got a customer that stopped by the booth last night that said he has 200 stored procs in SQL DW that he's orchestrating through ADF. In that case, that just means that you work on your, which is, it's kind of a nice sort of working model in that way if you have DBAs that like to write stored procs, because then your stored procs become disconnected from your pipeline. You never have to go and change your pipeline. You just change your stored procs. Yeah, using the power of the data warehouse. That's a great point. Yep, I think there's a question back there. Good.
How are you handling data duplication or upservice?
Data duplication. So the question was about data duplication. In that case, this kind of an architecture where you are using multiple different sources and landing data for different purposes, there will be a level of data duplication in that case, right? And that's sort of, think of it almost like a Lambda architecture or a speed and batch layer architecture. Land it into a staging area into Lake or Blob Store. We can have an offline discussion on this because there's a lot of different factors involved to think about and to talk about that. So data duplication is sort of an enterprise data warehouse problem that has been talked about for many years. And what happens in that case, I'm going to skip through these slides, and what happened in those cases back in the day when Teradata or other data warehouses were very, very expensive, data duplication was a very big problem. And now with blob storage and whatnot being relatively inexpensive, having that data sitting there becomes more of a pattern that can be more easily used, so that you can then carve off sections for data scientists, for data analysts, for different users within your organization. What we can talk about later is that does raise some governance issues that you need to be concerned about. And unfortunately, we're not going to have time to talk about that today, but we can definitely talk offline. So I'll finish up because I'm eating into Matt's time. So what I showed you was how to create the pipeline. We'll show you where the code is afterwards. Essentially, this was an ELT model, right? This was landing it. This was transforming it, extracting and landing, transforming. We used Polybase to scale load. Some other recommendations you can take away from here in terms of having these slides with you after today is to optimize your data loading into ADW we recommend using heap tables Within ADW, we recommend having turning off indexes when you load staging tables, and use partition switching to move from staging into production star schema tables. A lot of loaded stuff in, in those comments that I'm happy to talk about afterwards. Maybe what I'll do is write a more deeper blog on this, although this is a topic that's been talked about for years within the SQL community, so it's not all that different here in the Azure world than it was then. All right, so I'm gonna leave it there. I'm gonna hand off to Matt. So what's happened now in terms of our journey is I, as a data engineer, have built that pipeline. I have refined the data. I've handed off into the data warehouse, and my job is essentially done for that part. And now the data analyst is going to come in and is going to be able to see what he can do with that data.
All right, so all the pressure's on me to make it correct.
Make it look like something, yeah, because all I showed was data.
Got it. All right, so at this point, what we've done is we've shown you how to do some basic kind of how do I build a pipeline to get data from all these sources into a data warehouse. Mark walked you through a couple of different scenarios using Databricks, those kinds of things. So from here, we're going to pivot into SQL Data Warehouse for a moment. So I'll ask the question. Some of you are familiar with SQL Data Warehouse. For those that are aware, I apologize for the repeat. You probably know this. For those that aren't, I'm going to introduce it. So Azure SQL Data Warehouse is a relational data warehouse running in the Azure cloud. It's built on these kind of three premises. Again, you hear Microsoft, we're really good at marketing tenants. So our three tenants are fast, flexible, and secure. The idea is that it's obviously a cloud data warehouse, so you want performance out of this thing. We'll talk about what we've just introduced in the last week in that aspect. It's flexible, so it's built on an architecture that's a split storage and compute. So you have a storage layer underneath, and you can scale compute independently. So you're not tied to buying a size of thing. So if I need 10 terabytes of storage space, I don't have to buy 5 units of compute, for example. And finally, it's trusted and secure. So the idea is that this is many times your most critical data. This is all the data that you have in your company about your customers, your sales, all of that kind of information. So making sure that that data is secure, managed, and audited is something that is critical when you push this data into the cloud. You have to trust that Microsoft is going to keep that data secure and give you the capabilities of securing it yourself further outside of the cloud. So that way you can trust that not only is your data secure, but you're not going to end up in the news because your data was breached in some way. So what we introduced last week, on Monday of last week, is what we call our Generation 2, or Gen 2. Essentially, we talk about the 5-4-5. So we introduce 5 times the performance against our current offer. So we compare our Gen 1 versus our Gen 2. You'll see 5 times the query performance. Now, this is a general factor. We do see customers who get more performance out of the system, depending on your workload. But this is a general number we use. We have 4 times the amount of concurrent queries being able to execute in these systems. So data warehouses are typically very long latency, low concurrency type systems. So you want to run a lot of big queries, but you're not going to run a lot of those queries. You want to run things that are going to take hours or days in traditional data warehousing workloads. The ability to run more and more of those types of queries and being closer and closer to the data is critical as these data estates grow in your businesses. So we've introduced the ability to 4 times the amount of concurrent queries you can run in the system. Right now, this is an industry-leading benchmark of what you can run in any one of the cloud data warehouses out there. We've introduced 5 times scalability. So today, you can run in the number of hundreds of cores from a hardware perspective on your data warehouse. We've now introduced the capability to get over 4,000 cores in a single data warehouse. So a very large footprint. You can imagine the memory footprint that comes with this. We talk about it in tens of terabytes of memory running in one of these larger systems. So really giving you the capability to scale the system to meet your business needs. There's a massive amount of headroom. And finally, this is truly a fully elastic system. In theory, you could go into whatever is beyond exabytes of data. We don't have that yet, but in theory, there is actually no physical cap on the amount of data you can push into a data warehouse as of Monday of last week. So that was the marketing pitch of this. So from here, we're going to pop over into some actual code. So the way that we're going to do this is we're going to start in a data warehouse. So I'm going to start in SSMS. So this is a Gen 1 offer. So we're going to start there, and then I'll pop over to a Gen 2 offer, and I'll show you some of the differences between. From a user's perspective, we talked about these kind of sharded systems, these distributed systems. This is a shared nothing architecture, so it's a bunch of systems running under the covers, but presenting itself as a logical single instance. So you can see I'm connected to my Azure SQL Data Warehouse, and we're going to go actually look at the node count. So this is a Gen 1 system. And you can see what I've got right now is I've got 2 compute nodes, and I've got 1 control node. So this is just a distributed system. It's really simple. I made it very basic. So I have 2 slices of my data right now running in the system on 2 different compute aspects. And so what this does from a compute perspective is give you the ability to run those queries, those analytic queries, very, very rapidly. Instead of having one piece of equipment run a query and try to solve that, it actually is now split into two. And then there's a traffic cop, what we call a control node, or if you're from the Hadoop world, a head node, to be able to coordinate that. Now, I use an analogy to explain this. So does everybody know what an MPP system is? OK, so about a quarter of the room is still asleep from lunch, and the rest of you didn't raise your hand. So an MPP system is a shared nothing architecture. The idea is that instead of having one unit of work move all of your data, or in this case, perform a query, you actually have multiple units of work, and so you break down the work. I use an analogy of building a wall. So let's imagine up here in this open space, we're going to build a wall. And right here in front, we've got a pile of wood, box of nails, and a hammer. So great. We're going to share this as a bunch of us in the room. So we're going to I'll pick up the first two pieces of wood, I'll grab a nail, I'll put it in. Go to the gentleman here in the front, he'll come up, he'll do his job. And we'll keep working away around the room until we build a wall. That's one way to do it. This is kind of the SMP way of doing it. Now, in the past, what we've had is Moore's Law, and we said, hey, what we'll do is we'll build a faster hammer, right? So instead of going slow, maybe I can hammer faster. And we'll get to multi-cores, maybe we have 2 or 3 hammers, or we'll get to maybe a nail gun, right? We can go pretty fast with that. And so maybe it takes us a little bit of time, but we're pretty efficient at building a wall. Now, what if I have to build that wall that, say, covers all of Puget Sound? Right, well, that's going to take us a while, no matter how fast our hammers are, because we're kind of sharing the infrastructure. But what if we took everybody in the room and we did something different? We said, instead of us sharing the hammer in this case, we're going to each individually get a piece of the wall that we have to build. And we're going to give everybody in Puget Sound a piece of wood, a nail, and a hammer. And there's one person who says, everybody ready? And everybody lines things up, and they're holding their nail. We say, go. Boom. Everybody hits the hammer. Wall built in a second. That's the idea. So we're distributing the work across many, many nodes. In this case, I've just picked 2 just to give you an example of what's happening. So the second part that we have to understand is what Mark kind of alluded to just a minute ago. We have a technology we call Polybase. Now, is everybody familiar with Polybase? Yeah, good. We use all kinds of internal code words, and I apologize for us explaining them here in public. What this is the concept of having your data stored in a system that is not actually sourced inside of SQL. And I'll explain that in depth. What you're about to see is a table. I'm going to go look at what we call an external table, and I'm going to do a count of it. Now, what? Uh-oh. Yeah, this is the problem. When you come in from another room and you connect, yeah, there we go. And you try to get things to work. Am I on the right? Oh, I apologize. I'll have to connect here in just a second. It connected to the wrong data warehouse. So what this will do under the covers is it's actually a table. It presents itself as a table, so you can see I'm doing a simple select count star. So it's saying, oh, I want to connect to a data or to a table, and I want to count just the number of rows. And what this is doing under the covers is the data itself is not actually stored in the data warehouse. In this case, it's actually in blob storage. So the system will go out, generate what we call a distributed query. It'll reach out into that blob storage in parallel with all of those nodes. It will read, in this case, a bunch of CSV or TSV files. It'll aggregate that information, count all of the rows in them, and then return that to me in a simple query. So as a user, I don't actually have to know that my data is in my data warehouse or was landed in blob storage. I can actually interact with it just as I would any other kind of T-SQL-based kind of query. So I can go select star from table. Now to prove this, and I'll make the connection back here in just a second, this is actually the backing system of that data. So it's just a bunch of files sitting in blob storage. So this is that data that was uploaded. We put it into a blob storage location, and now you can actually see it. So the system is able to go through and parse those files and interact with it. Now, typically, we have the scenario where customers are landing data, and now they start to ingest it. So we have what's called a CTAS statement, or create table as select. So we can go select out of these and can generate a new table, like a staging table. Then go through that transformation process of taking that data, transforming it into the shape that we'd like, and then moving it into our production tables for modeling and serving later into our system. So in case of a report, we would then have the updated data. As Mark mentioned, customers do this quite often. So we have customers who run hundreds of pipelines this way. You're able to do this directly out of scripts, out of T-SQL, as I've done here before. Or you can do it through ADF pipelines. There's a bunch of mechanisms for doing this. But in this case, we're just going to simply back it that way. Now, I'm going to have to reconnect here. For some reason, this connected to, I have 2 instances running here that I want to show you, and this connected to the wrong one. So we'll try that again. We'll get on the right database. And so while this is running, right now the system has gone out, and it's now in the process of reading those files. I ran this earlier on a bigger system. That's why you see my 15-second kind of note. But ultimately, this will come back and return about 6 million rows. And it's read all out of those CSV files. Because of its distributed nature, the more power we give to the system in the form of compute, the faster this operation will run. So as we split those files apart, we're actually able to file split and be able to read all that data in parallel and then process it. So this is just a simple example of doing that. So the question is, if you had one large file, would you have to split it yourself in order for the nodes to be able to take advantage? Is that correct? Okay. There's an it depends answer. If the files are something like CSVs, where you don't have to decrypt it first, so like a gzip file, which you would have to decompress first, no, you would not have to split it. So if you had one large CSV file, it would be perfectly fine. We do file splits, and we're able to read in parallel. Something that's zipped, we have to unzip first, and that will then be pulled in serial. So it depends on the source format of the file. If it was a bunch of text files, CSV files, those kinds of things, you can pull it in. Yeah, it'll do it automatically. The system does this, it handles it for you. So then as we kind of pull down, so this is the beginning of kind of that summary data that we're going to look at to build that chart. Now I'm sure you're all familiar with the data model that we have, so D0, D1, D2, that all makes sense. What this is showing you is this is actually the different kind of drought tolerance conditions. So a D0 is, hey, we kind of a little drought. D4 is like, there's not been water in California for months. I live in Southern California, so this is something we've talked about for the last several years. And all we're doing is a simple calculation. This is a pretty straightforward one. We're just get the data over a county, a particular county in California, and we're going to look at it over a period of time. And so it's a simple calculation. Now again, this isn't a lot of data. I'm not showing you, billions of rows here. This is pretty simple. But it gives you the idea. From a user's perspective, it's just a simple operation. Under the covers, this can be multiple nodes running many different kind of operations at scale. So this could be over a terabyte, 10 terabytes, 100 terabytes, petabytes of data that we could perform this kind of operation. Because it's a language that's very synonymous, people are very familiar with SQL. You saw Mark immediately jump to his skill set of, hey, I know how to write SQL, so I'm going to write this in Spark SQL. You don't have to retrain your staff on how to use this kind of scale. It's not some special tool. It's just simple SQL language to be able to get at it. This happens to be the county I grew up in, so that's why you get to see the demo of my stuff. Ultimately, this will be the query that we're going to run for that visualization. So what it's doing is it's looking at a combination of things. It's going to look at the drought level, and it's going to look at the population by country and year. So we're going to look at the drought conditions in the United States several years, and we're going to see that very quickly I can run that query. Now, again, this isn't a large data set. Ultimately, it returns less than 1,000 rows, but this is something that you would commonly do in a dashboarding scenario. Hey, go get all of my product sales information over the last, say, 90 days and show me the trend of that. So this is a very common use case for this kind of data warehouse workload. So that's kind of ultimately where we will end up. Now, the second thing I want to do is I want to switch over to the other instance, and I'm going to double check that I'm connected to the right one here. So we're going to run a different query. So this is going to show us year-over-year water usage. Now, I know water's not the most glamorous thing, but this is a good set of data that we've now aggregated. And if I run this query, it's going to show us some pretty good aggregate of what's happening. And so now this is a different system. And again, you see I put some timings on there, and this will take just a little bit of time. Right now, the system's now running this aggregate. Now, this is a view, and I've cheated because I didn't show you the view. But what this is it's going and trying to do this calculation of something that maybe you would do in like a report where you say, okay, show us how water usage has changed over time. So you're starting to kind of answer those kinds of questions. Well, it seems pretty straightforward, right? You can see a year calculation and kind of water usage over different categories, and it's pretty straightforward on what the result is. What's interesting is how this is built. Anybody want to guess how many rows that came from? Is there a guess in the room? How many rows did I start with? 6 million's in front. Anybody got a number higher or lower? So let's do this another way. How about over under? Let's say this is 1 billion rows. How many hands do I have that is over 1 billion rows or under 1 billion rows? So let's start with over. Who thinks this is over 1 billion rows? How many under 1 billion rows? So you guys are about half and half. So I'm actually going to show you. Oops. If we roll back up, these are the two tables that we're interacting with. The largest table is about 14.5 billion rows. And it's a join between that and another table that's a couple million rows. And that was done in just a couple of seconds. So the idea is that we can take this kind of data, and again, this is actually a very small system. It's not large at all. But this is our Gen 2 offer, so it's able to run through that data very, very quickly. Now I'm going to show you what that query actually looks like. This is the backing data behind that view. Now this is a lot more complex than what we just showed you. And I'm not going to walk through the depths of this query because it's not important for what we're talking about here. It's really just a simple CTE expression. We go do some calculations up front on some of the data, and you can see the join of these two tables here. So I put the row counts here again. And then you can see where we're doing a simple where and group by. And then we aggregate it again in a second CTE based off the first one. And then finally, we return these results out. Now, this looks like a lot more common data warehouse query. Right? The one I showed you earlier was very simplistic. And this is much more common as to what you would do or the kind of code you would write in a situation like this. You're doing some aggregations at scale. Now, again, this is only 15 billion rows, and I use that word lightly, 15. It's not very many. We have customers who run hundreds of billions or trillions of rows. I've done another demo on stage where I do a 10 trillion row calculation by asking for dates from the crowd, and it runs in 90 seconds or less. This is the capabilities of a system like this. So being able to do a very complex query like this over very massive amounts of data to get insight out of it very, very rapidly. And that's what this system is built for. So now that we've done this, I know yeah. So the question is, where's this data stored? So this data is actually inside the SQL Data Warehouse. So we've pulled it in this case. Yeah, so in this case, the way that this data was ingested was we actually took it out of the blob storage and we pulled it into the data warehouse using Polybase. So we just imported it using that kind of CTAS operation we talked about. We put it into the table and started messing with it so that we could show kind of the power of the system, both connected and not connected to the actual storage. Now, I'm a Windows guy. I've been around Microsoft for a long time, so I like SSMS, but not everybody lives in the world that I live in. So we have enabled a bunch of different scenarios for connecting to this data. I'm going to show you a couple of different ways. Here's the most glamorous demo you're going to ever see. Look, it's SQL command, right? So this is a SQL-based product. It interacts and represents just like you would expect it from any other kind of one of the SQL aspects. So you can use SSMS, SQL command, any one of the other connectivity places to go to our data warehouse. So I can just do a simple select that version, and you can see there's my data warehouse. I can do the same thing through using the new SQL Operations Studio. It's the same thing. So connecting to this is a ubiquitous concept. You can connect to it from basically anything you can connect to a SQL Server database. And that includes all kinds of different things. Switching over to my analyst view, I've also connected this into my Excel report. Now, we know that the most used analytics tool in the world is Excel. Everybody uses Excel. Everybody wants to pull the data in and build their own charts, right? As much as we love Power BI and all the third-party BI tools, this is where people spend most of their time. So you can see I have that same query, the one we're going to look at here. And I'm going to run it again, because apparently my connectivity here is not that great. But you can see right now it's going out to the data warehouse. It's going to run the query, and it just pulled the results back very quickly. It's not a hard operation to do. From here, it's now in my Excel, and I can go ahead and do any kind of graph building or chart building or merging of that data that I would in Power BI or in Excel any other way. Finally, we're going to build that chart. So you can see I pulled that data, that same exact query. It's connected to the same place that we did before. I'm going to build the chart. And so this is directly connected in Power BI, and I can simply just build a chart. I'm going to go ahead and build like a stacked chart with the population overlaid over the top of it. And I can simply start to put data in here. So I could take my date. Sorry, my eyes aren't so great. I'm going to grab my population, put that in my line value. And I'm going to put my shared data here as my date. And then I'm going to start building out my values. So I'm going to put the drought conditions just kind of stacked on top of each other. Now, I'm not a super big fan of all the basic colors that we've given, so I'm going to flip these over to some colors that I like. I'm just going to pick the kind of red, pinkish colors here. And I'm going to recolor my chart. And what we've been able to do is we've been able to take all that weather data that we had originally. We've been able to run it through Azure Data Factory, in Databricks, process all that data, munge all that data, transform it, land it in blob storage and stage, ingest it into SQL Data Warehouse, and then ultimately build a query and view in Power BI. And we've done this in roughly 25 to 30 minutes. Now, Mark and I cheated a little bit. We set up the system ahead of time. We had our tables created. We had the services provisioned. So this should take somebody who doesn't know what they're doing, if you're following the directions, probably a day. It's really not that hard to go from just a set of data and starting to build insight in these systems. Now, if we go back and map to our presentation, we want to see how well did we do? How close were we? So pretty close. Pretty close. The data is actually a little different because from the time we started this, and I built this chart originally, until the time I just built it, we actually added some data. So really, really close. The aggregations are about half of 1% off. But you can see we can go from kind of getting some basic data. We merge things from a bunch of different sources. Traditionally, what people have done in these data analytics scenarios is they've gotten used to the fact that they have the data. I have data in my reporting system. I have data in my OLTP system. I have data in whatever source systems I have. And they haven't thought through the ability of being able to pull from all these disparate sources. Merge all of that data, be able to build it at scale, expose it to your audience, and then ultimately build reporting. Now again, this is a very simple walkthrough, a simple story arc to get you from A to B to walk you through kind of the details of this. But the idea is that you can take these analytic solutions in the cloud and use this as a platform to start to build out your entire data estate. Some of the things we didn't talk about is now if we took that architecture that we started with, you'd be able to start adding in different components. So if we landed data in data blobs, for example, in the blob storage system or Azure Data Lake, from there you could go very quickly light up something like Azure ML, Revolution RStudio, those kinds of things, and be able to do deep data scientist analytics across that data. You could find all kinds of insight out of that data, and from there connect directly into something like SQL Data Warehouse as the result of that. So maybe you're doing trend analysis, or maybe you're doing fraud detection, or any one of those kinds of scenarios in your data sets. Or you could do something like data scoring. So as the data's coming in, it's being scored, and then push those scores into something like SQL Data Warehouse. Where you have these kind of different roles. So I, as an analyst, I don't really care how you got the score. I just trust that your score is correct. You're the data scientist, and so I'm going to be able to use that in maybe telling me what customer is likely to churn based on the algorithms that you built for, say, churn detection and the data that you have. And so it's really easy to start to combine and mix these products. The biggest takeaway out of this session that you can have is that as you move to the cloud, or as you're augmenting the cloud experience that you already have, it's that these data tools are allowing you to be able to move in and out of the scenarios that you need very, very rapidly. Now, again, in 25 minutes, we built a kind of contrived demo to get you from 0 to hero in just a few minutes. But the idea is that from here, you could take this as a basis and start to build out the rest of your estate. You could think about how do you go this data, say, partner companies or different parts of your company that are interested in the same data but in different views. Or start to build into some of the machine learning, start to take advantage of, to get insight out of your data and really build out this entire portfolio of data that can now serve and drive your business forward. So with that, we're going to kind of roll.
Before you go to the last slide, Matt, there's one thing I just wanted to make sure that I point out, because I realized that as he was talking, it's a good point that we didn't really explain Polybase up front, which I kept hitting Polybase, like, well, nobody, we don't all know what Polybase is. But one of the things that you should take away from what you see what you do from a data analyst within data warehouse versus the data engineer who is loading up those data marts through ADF is that there's many different ways to access that data. So Matt was showing you ways to be able to ingest the data directly through external tables is one great way to do it. And with ADF, I think the question came up earlier of, can I essentially write these in stored procs and do the same thing? It's absolutely, you could leverage what he showed and do that in T-SQL within SQL Data Warehouse and just automate that and orchestrate it here as activities through a data factory. So those copy activities are doing really essentially the same thing. Taking data from sources, putting it into blob, and polybasing that into ADW. It depends on where you'd rather have that sit. But one of the things I wanted to show is that while Matt was talking, my entire pipeline end-to-end succeeded. And you see at the bottom, this was the debug view, right? This is in design mode, debug. Think of it as you're in Visual Studio writing an SSIS package in SSDT. You get this pretty much the same experience. And so what happened at the end was I was able to send myself an email saying that that succeeded because I'm calling what we have now in ADF is a web activity that is calling logic apps. So I have a very simple logic apps. This is about as simple a logic app as you can get. That is sending myself an email saying that my pipeline succeeded or failed. So the fact that you can call a REST endpoint is a very, very important extendability piece within Data Factory that you can leverage as you build these pipelines. So in this case, I just send a logic app. I just call a logic app that sends me an email. And then last thing I want to show real quick before we switch to the ending slides is back in my Data Factory, this was all in debug mode. When you're done and you've done, so to finish out the story arc, Matt interactively explored the data, found the key points he wanted to display in a report. This was all just really designed. This is not operationalized. When you operationalize this data loading, you'll want to use incremental patterns. So I have an example in here that you'll see in the GitHub that has an incremental pattern capability. And we use a lookup function within ADF to go and look up what is the existing data in Data Warehouse and what is the delta coming in from these files. Because these files that we have, the ones that we never got a chance to actually show you this, but we have these source files with all the measurements in it, are very, very large files that we got from NOAA and from other sources. You know, a lot of it is weather sources. And in that data, you don't want to have to load. Actually, let me just do a preview. It'll be easier to see. So within ADF, you can actually preview your data. You don't have to go out into Excel or some other tool to preview the data. You don't want to have to reload this every night and every day. You just want to do deltas. So the way you do a delta load in ADF is that you're going to use that lookup capability, and you're going to look to see existing values versus the delta values and only load the values that have changed. That's all built in there as well. And then lastly is that when you operationalize this, you make that scheduled trigger that's going to run every day or every night to load your data into Data Warehouse. You'll want to monitor it. So the common ways to monitor pipelines within ADF is to either use this visual tool directly within the portal within ADF, or you can use Azure Monitor. So the alerts and the telemetry is also stored within Azure Monitor, and you can always this way. And you can always view the data through OMS or other tools like that, or just use the screen here in ADF to view the status of your pipelines. Bottom line to it is that as a data integration pro or ETLer, you're going to want to make sure you're monitoring your pipelines daily. Anything else you want to say to that?
Yeah, no. I think as we close, kind of the thing to think about here is in a 60-minute session or so, we can only scratch the surface. I mean, we could spend hours in depth talking about how do you set up an ADF pipeline correctly, how do you set up SQL DW correctly, what are some of the best practices around each one of these. This is really just a primer on getting started with some of the key things that you need to consider as you're thinking about these products. The takeaway, again, the key takeaway here is that the Azure cloud enables you to build these systems very, very rapidly. We've done a lot of work making sure that the integrations between these products is very, very deep and very, very easy for you to use. Some of the things that you haven't heard, so when we talk about things like Polybase, I've simply said, you can take an external table concept and point it at blob storage or say data lake. But Data Lake has also done the work to be able to do from a batch job in Data Lake, for example, to be able to push the results of that batch into SQL Data Warehouse. So if you happen to have deeper skills in, say, USQL or that side of the world, C#, and you're more comfortable in that language working within Data Lake, you're more than allowed and encouraged to work from that model instead of having to go learn a new language, say T-SQL to you. Or vice versa. If you're very versed in, say, SQL-based languages, you can work from that model. And so a lot of times it really comes from your perspective on where you're coming from and how to get enabled. We've also simplified some other things, as Mark walked you through, the creation of data from a source through a copy command. There's a wizard for this. You can literally just open it up, and it's 6 or 7 screens of click, 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 and add some details, and you can actually move data through a simple wizard in a browser, being able to set up these pipelines. Or within Azure SQL Data Warehouse, the ability to go right to the portal and say, I have a data warehouse that I've set up. I'm going to click a button and open up an Azure analysis model for additional kind of caching tier or additional reporting, depending on kind of the scenario you have. Those are all things that can be simply done by clicks in a browser. And so these integrations are a different way than, say, if you were used to building on-premises systems. As we used to think about this 5, 10, 15 years ago, we used to have conversations that sounded like, hey, go start budgeting for something that's got 2 commas in it because you're going to have to build this big pipeline with a bunch of resources. We're going to spend a lot of time up front in thinking about how we're going to do this correctly. In the cloud, you can very quickly build these systems up, tear them down, and rebuild them as you learn. So the idea is that get your data out there. It's like DevOps with data. So you kind of have this data operation where you're constantly learning and growing and changing. And the cloud enables that with you. As your business grows, the services scale. As your business evolves, you can start to add the different components that make sense to your business, whether that's machine learning, whether that's aggregating things into a data lake as you bring in IoT data. So it really gives you the capability to land your data and grow and expand in Azure as you go. We'll stay out for a few more minutes. We'll end with kind of some of those resources that Mark had pointed out here. So some additional places to get details. You can obviously read about the 2 products that we've talked about primarily here, Azure Data Factory and Azure SQL Data Warehouse. You hit the azure.com site. There's obviously a lot of information on a lot of these products. You can follow us on Twitter. We've given you a couple locations, as well as all of the scripts we showed here are on the Azure Data Factory GitHub that Mark has, and so you can go find all the details there. We will hang out, answer any additional questions you have. I know it's a right after lunch session. Usually I bring socks and throw them at people, so that usually keeps people awake if you can answer questions. Unfortunately, we ran out of socks in our booth today.
Sorry, clean socks, Matt, or just socks?
No, not
your
no,
socks.
clean ones.
Oh,
Yeah,
okay.
yeah. No, I don't bring dirty ones from home. Sorry.
Gosh.
But if you do have more questions, there's a lot of people out hanging out in the expo section that can answer questions about all of these technologies. So I encourage you to go find one of our experts. Usually these are the product folks. So Mark works in Azure Data Factory. I work in Azure SQL Data Warehouse, and we'll be happy to answer any questions you have. With that, we appreciate your time, and thank you for coming.